I always address the homework. But let me get through the notes and then we'll go to the homework, okay? We were looking at co-function and double angle identities. We practiced the double angle, and that's the slide we need to finish. Then we're going to do some extra practice to make sure you really understand how to do it. And then we have the half angle identity to look at. The co-function identities involved, remember, pulling the 7-1 formula and then applying the unit circle and just cleaning it up. Here is the double angle identities, and we derived them so you understood where it came from. Then this is on your formula sheet. Remember, you have 3 choices for the cosine double angle. And remember, it does not matter which choice you pick. You will get the right answer as long as you are simplifying it correctly. This problem is on your test, which is next week. Not this exact, I'm just saying there's one just like this on the test next week where you have to take a higher multiple of an angle, break it apart into a double angle and whatever's left over, apply the 7-1 formula, which is on your formula sheet, and then apply the double angle formulas. Seniors, today is the last day for nominations for superlatives. You should have received an email. There you go. Apply the double angle formula, and then you just clean up what you can. And remember me saying that this particular problem is kind of stressful for people because you start here, and the idea is clean this up, and then you end up here, and your mind thinks, well, that doesn't look any cleaner, but that actually is the answer. Because the goal is to take a multiple of an angle and reduce it down to just a single angle that can be evaluated. And we are not evaluating these. We are just manipulating them. Yes. So then we were right here practicing the double angle formulas, like actually finding them from a picture. Remember, the setup here was they give you one trig function to start with, and they tell you what quadrant you're in. You have to draw it. Then you need to find the missing side using the Pythagorean theorem. You need to make sure your negatives are labeled correctly. So I don't know if you want to make a note to yourself. Watch out for signs. And what I mean there is positive or negative. Like, label them based on what quadrant you're in. Then it says, hey, find the sine, the cosine, and the tangent of the double angle. And that is as simple as finding the formula from your formula sheet and plugging it in. You do have free choice on cosine because there's 3 choices. I showed you just by pulling 2 of them. It does not matter what you pick. If you do the math right, you should still get the same answer. And then we did tangent. Tangent's really ugly just because it's a giant fraction and then with more fractions within it. So just put it on paper and then go to your calculator and type it in so that your calculator can do the math there. The answer for this problem is always fractions, and they're typically ugly. I wouldn't say these are necessarily ugly, but I'm talking like in the hundreds, 200s, 300s. I've seen that before in practice problems, and that's okay. So don't feel like you're doing it wrong just because you get a really ugly fraction. There's one of these on the test. There is one of these exact questions on the test. All parts. It's on the test. Okay? The last part right here, it says the quadrant in which 2 theta lies. It wants us to find that. You need to understand what it's asking for here. This is the double angle, correct? That's the double angle. If you look up here, this was not the double angle. This was the just plain angle, the single angle, I guess you could say. And it was in quadrant 2. Okay, this is saying, tell me where the double angle lies. Well, you just found the sine, cosine, and tangent of the double angle. How do you determine what quadrant you're in from what you found? Look at the sines of cosine 2 theta and sine 2 theta. What did she say? For the clinic? You're going to get a camera shoved in your ear with a doctor on the computer on the other side.
I see what you did.
It's going to be like you're talking to Sheldon from Big Bang Theory. Look at the sines of the cosine double angle and the sine double angle. There's a reason I wrote it like this, because I wanted you to think of it as a coordinate point. So the cosine double angle, which is right here, what was the sine of it? It's positive. The sine double angle was negative. Okay, so what quadrant is positive then negative? It's 4. Right? Go right and then down. That's quadrant 4. Someone draw an arrow and say this is quadrant. You can write Q4 or you could write the Roman numerals. It's up to you. It is as simple as looking at, now you might think, why didn't I look at tangent? Well, because tangent, remember, is positive in 2 quadrants, so that's not going to help you. Negative in 2 quadrants, that's not going to help you. This is, if this exactly like this tells me, if I look at the cosine, then the sine, remember to do it in that order. Why does it need to be in that order? Cosines x, sines y. So be careful. Don't go in the order of the A, B, C, because then you're going to switch it, and it's going to be wrong. A checkpoint, so a little checkpoint, is to say to yourself, well, if the single angle was in 2, right, and I'm doubling the angle, it makes sense that I landed in 4. Okay? Now that's not the only way, like that's not 100% guaranteed, because you could be right there around the axes, but it's a good little okay, it's within reason. If I was at a single angle in quadrant 2 and I just doubled the angle, it makes sense that I probably land in quadrant 4. You got to think of that rotation. If it's in 2 and I double it, makes sense that I'm now over in quadrant 4. Okay. We have 2 extra practice problems from this to make sure you understand it, because I feel like one's not enough. So let's look at it. E1.
For whenever you are finding the double angles, do you always just use the formula every time? Every just that? Yeah.
Yeah. Get your yellow formula sheet out, because you're going to need it right here. All right. Let's look at this one. It says sine of theta is negative 7 over 25, and then it gives you this nice little description of where theta is. This is how you read this. You say to yourself, always read it from the middle, you say to yourself, theta is in between 3 pi over 2 and 2 pi. Now, I think in the My Math Lab homework, they straight up say what quadrant. Am I correct?
Yeah.
Okay, so this is a kind of a more advanced way to say it, but it's always revolving around those quadrantal angles. So if you look at your unit circle on your yellow formula sheet, find 3 pi over 2 and 2 pi, and then the space between is the quadrant you're in. So you're in quadrant 4. The Bradford pear trees are in full bloom because it thinks that this is spring, and it's not. I gotta start thinking, all right, we're in quadrant 4, and we're trying to find tan of the double angle. Now, we're not finding all 3 trig functions here. We're just practicing finding one from the given information. So the question is, I just want to know, do you know how to draw the picture, label the triangle, find the correct missing side, then pick the correct formula? So I want you to try that right now. Draw the picture based on the quadrant you're in. Label the correct sides based on the trig function they gave you. Then find the correct missing side. Then go ahead and write the correct double angle formula that you're going to use. And then let's check it and see if you got all that right. Okay, I'm going to see if you've got the setup correct. You can keep working if you feel like you're on a roll. So we've already decided we're in quadrant 4. So I'm going to sketch a picture of a triangle in quadrant 4. Remember, you always start from the origin, shoot out, and then collapse to the x-axis. Don't ever go to the y-axis. Theta's right here. Then you label it based on the trig function that they gave you. They're giving you sine. You need to remind yourself what sine stands for. The geometry definition is on your formula sheet if you forget it. The leveled up college pre-cal definition is it's y over r, or opposite over hypotenuse. So the opposite of theta is 7, and the radius is 25. Then you have to decide what number needs to be negative. The hypotenuse, r, is never, ever negative. So the 7 has to be, also we're in quadrant 4, y is negative in quadrant 4. Now when you go to find the missing side, don't let that negative throw you off, because I know some of you still struggle with putting parentheses around a negative number before you square it. And if you don't put parentheses, it's going to come out as a negative, and it's not supposed to be. It's supposed to come out positive. So when you go to set up your Pythagorean theorem, right here, we're missing the x coordinate, so I'm going to write x squared plus. In the calculator, you technically would put -7 in parentheses, then square it. But if you truly understand that we're dealing with just positive numbers here, you can even look at my paper. I personally, because I don't want to mess up with my negative, I just say to myself 7 squared. I do that so I don't accidentally pull a negative in when I'm not, if I type in the calculator. It's up to you to decide how you want to proceed with that. Just know it's supposed to come out positive. You end up with 24, right? Y'all get that? So you would do 25 squared in the calculator, then subtract 49, and then square root it. So the x coordinate is 24. And now this is not saying find all 3 of them. This is saying just find tan of 2 theta. So you go to your formula sheet. Pretty much every single question involves looking at your formula sheet, because I'm not expecting you to memorize these formulas. Pull the double angle formula for tan. There's only one. now know how to plug it in. We need tan of our picture. If you forgot the formula for tan, it's at the top of your formula sheet, the geometry version. The leveled up version is y over x. So tan would be -7 over 24, right? Then 1 minus -7 over 24 squared. And that is very ugly. I hope you'll just write it on paper, then go to your calculator. You need to put it on paper because I will give partial credit. You know, if you have this on your paper correctly, but then for some reason your answer is wrong, that it tells me you typed it in wrong, I would give you most of the credit because you have the hard work done right there. So you're going to type it in, get a big old fraction bar, do, now since there's a lot of fractions here, let me show you a technique. Just type what you see. I see 2 parentheses, -7, divide 24, close parentheses. It will calculate it correctly that way. Then I see 1 minus, parentheses, -7, divide 24, close parentheses, squared. Remember me telling you? Ugly fractions are common here. So when you see that, you probably think there's no way, but that actually is right. -336 over 527 is the answer. All right, E2 is to see if you recall how to find the Pythagorean theorem when a radical is involved. All right, so start E2. Figure out what quadrant you're in, draw the picture, label the triangle, set it Pythagorean. Let's see if you get the correct answer for the missing side. Which part? The top? Quit watching basketball. I don't know, you're the one with it in front of you. All right, let's see if you started it the right way. Okay, so you should, with degrees, it's easier probably to determine what quadrant you're in. But remember, you do have a unit circle there, so don't be a victim of it. So if we're between 180 and 270, that means we're in quadrant 3, right? And they're giving you tangent. The leveled up formula for tangent is y over x in quadrant 3. So draw my triangle. Remember, the triangle juts out from the origin and then collapses to the x-axis. Theta always goes in the corner. Now you're going to label y is root 19. X is 9. I'm going to draw in red. Watch out. Think of that GPS that's telling you, watch out, object on the road ahead. What's the watch out part here? What's the problem? Well, no, I mean, that is a watch out. Before that, they're both negative. Tangent is deceitful if it's positive, because if you're in quadrant 1, everything's good to go. But if you're in quadrant 3, then you have to remember, wait a minute, that's actually negative and negative. And it does matter, because when you go to plug in cosine of the double angle, you're going to end up using the negatives, which in this case they get squared. So I guess there it doesn't. So you could get lucky there if you forgot, but it's not always that way. So watch out. We're going to make note. Signs in quadrant 3, they're both negative. So right here, I'm going to put negative and negative. Okay, so now we're going to do the Pythagorean theorem. And like we said over here, the negative numbers plugged into the Pythagorean theorem always come out positive. So if you don't want to write the negative there, you don't have to. It's showing that you're intuitive enough to know that this is going to yield a positive number, so I'm not even going to fool with the negative sign here, since I've already got something else complicated coming up, and that's the radical. So you've got the square root of 19, but that's going to be squared, and then we're trying to find the radius, right? So this is 81. Remember, when you square a square root, they cancel and you're left with just the number. And the good news is, if you forget that, because your mind is about to explode with information, you can type it in your calculator. If you type square root 19, come out of it, and then hit squared, it will tell you, hey, it's just 19. So if you forget that little concept that that's just going to cancel, then go to your calculator and type it in to check yourself. So 81 plus 19 is 100. So R is 10, right? Now, if you're sitting here thinking, no, wait a minute, I thought the hypotenuse had to be the longer side. It is. The square root of 19 as a decimal is smaller than 10. So although it looks like a bigger number because of that square root, it actually is smaller like it's supposed to be. All right, so now we're going to find the cosine of the double angle and put an asterisk here, because that means you have free choice between 3 formulas. Y'all know me, I went with the first one just to be easy on myself. Like, there's a what is it called? There's a scientific fact. I'm about to get real deep with y'all. Like, there's a scientific fact that when you have too many choices, it stresses you out, and then you don't appreciate things as much because you just got too much. It's the whole concept of, and I've read about this because of my mom life. I have boys, I have kids. If they have too many toys, they don't know what to play with, because it's an overload. But if you narrow it down to just like, you got 5 toys, they'll play with something every time because they know, oh, all right, I'll go with that one, I'll go with that one. Same concept with formulas. When you got too many choices, it's like a sensory overload, and you're like, so I always just go with the first one, because I'm like, I don't want it. I'm done with making decisions. I just want to plug it in and be done. And now I'm off my soapbox. Sorry. Okay. Now you're going to plug in the cosine fraction and the sine fraction from your picture. So the cosine is x over r. So that'd be negative 9 over 10. The sine is y over r. And I just realized I left off. Don't forget right here. Squared, because the formula is to square them, which is why the negatives here really actually don't matter. It matters for the picture, and it could matter to know had it not been cosine, if it was like tangent or something. Now, that is hideous. I'm not asking you to clean that up on your own. I would go to your calculator. I would even just enter it using the division bar. I'm out of the square root 19, though. Be careful there. I would enter it in the calculator exactly how you see it, and then I'd go ahead and put right after it, hey, calculator, keep it in the fraction. 31/50. Okay, so while it's a lot of information, and when you look at the question, you're probably like, I have no clue what it's asking. Now that we've practiced it 3 times, do you feel better about it? There's one of those on the test. The one on the test will mimic this, where I say, you know, here's one trig function for the single, here's the quadrant, find all 3 doubles, and tell me what quadrant the double would be on. That's what's on the test. Okay. You can go back to, yeah, because were you at the nurse? Okay. I'm going to go to homework to help. All right, half angle. So, same concept. Instead of the double angle, we have the half angle, but it's the same concept. I will agree to say that the formulas are annoying. Because if you look at the formulas in the boxes right there, we're not even deriving them. I don't want to derive that nonsense. But if you look at the formulas in the box right here, they're ugly. I agree with you on that. But it's the same approach as before, okay? All right. If you do want to, yeah, if you do want an understanding of why these are the formulas, you can turn to page 511 in your e-text. But I doubt you're going to do that. All right, so let's look at it once again. Let's understand what we have here. First of all, you have the label half angle, and then you have this right here, here, and here, which makes sense. You're cutting something in half, okay? So if you see examples with fractions, that's your indication. This is probably going to be a half angle identity. You have, instead of 3 choices for cosine, you have 3 choices for tangent. You have 3 choices, okay? I'm going to put a box around the one I typically use, and that is this one. 1, there's no square root, right? 2, on the bottom is just plain old sine. Instead of like 1 plus cosine, because then you got it on the bottom, you don't have like denominators. So this is the one that I typically go for, but you do have 3 choices, okay? You're going to make a note right here. Ask where half angle is, and what we mean by that is quadrant 1, quadrant 2, dot, 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 dot. You ask yourself, where would the half angle be? That's kind of like a checkpoint. That's how you determine what sign your answer should have, whether it's a positive or a negative, okay? All right, so let's just dive into a tangent, because you know, let's just rip the Band-Aid off and do one of the more challenging ones. It says find tan of pi over 8 exactly. This means no decimals. Okay, so now for a reference, don't write this. If I said find tan of pi over 2, you would go to your unit circle, you would find pi over 2, you would look at the coordinate point, which is 0, 1, correct? Tan is y over x, so So it would be 1 over 0, which is undefined, right? If I said, tell me the cosine of pi over 4, you would look at your unit circle, find pi over 4, and you would say, oh, it's square root of 2 over 2. Yep. Okay. These answers are what's called exactly, meaning it's a nice fraction that is not rounded at all, and it tells me the exact value of cosine of pi over 4. This is the same concept, but you cannot find pi over 8 on your unit circle. Look at your unit circle. There's no pi over 8. So that's why we have to use another formula. We have to use a formula to basically calibrate it into something that we can evaluate, okay?
Is it always going to be a fraction, or is it ever whole number? Because it said no decimals, so could there ever be like 1, 2, 3? There's always a fraction.
No, all I said was just no decimals, which means it leaves it open to, it could be a whole number can be written as a fraction over 1. So when I say no decimals, all I'm saying is there's just no decimals.
Yeah, I'm just saying like could there ever be like just
Well, I can't think of every possible example that,
but there's a possibility.
yeah, so the concept is instead of trying to think of what's allowed, just think of what I'm not supposed to get to. You're not supposed to have a decimal, which means if you end up with a fraction, great. If you end up with a whole number, great. Cannot have decimal. And then you don't set yourself up for that expectation if something is a whole number. This says, then check your answer using a graphing calculator in radian mode. Okay, so this is one of those things where I like these questions because I know for a fact I'm going to get it right or not when I'm done. Go to your calculator, change it to radian mode. And then you're going to type exactly what it said, which was tan of pi over 8. Right? That's the answer. So you already have the answer in front of you. Now you just got to figure out how to get the answer, like, with nice, pretty numbers, no decimals. And then we can type what we get as our answer in, and if it matches that, then we know we got it right. Okay? Disappeared. All right, so let's set it up. We have tan of pi over 8. The first thing we need to do is let's get it out of radian mode because it's harder for people to understand radians. Do you remember how to convert from radian to degree? You should. Test it over it. So somewhere over here, just say to yourself, okay, I want to get out of radian mode. So pi over 8. Remember, whatever mode you're going to is what needs to reflect in the top of the fraction. So if I'm going to degrees, I need it to be 180 over pi. So I'm going to make a note that we're going to convert. Now, pi's cancel. You go to your calculator and you would do 180 divided by 8 and keep it as a fraction. What do you get? You get 45 over what? 2. Perfect. You know what's funny is when I do the notes myself, I went to the decimal and then I wrote a note like, okay, so we got, what's 45 divided by 2? It's 22.5. So I wrote a note that I've got tan of 22.5 and I said to myself, what is that as a fraction? So I could have just left it as a fraction right there. I said all that to say to myself, why didn't you just stay as a fraction? All right, so tan of pi over 8 is actually just tan of 45 degrees over 2. Well, look at that. Over 2. What formula do you think we're going to use? One of the formulas that's over 2, right? You see how it mimics exactly what is it, tan? it mimics exactly what formula you need to use. See that? So that's your indication. I've heard people say, I don't know when to use the half angle. When you take what they told you to find, get it into something you can manage, and if it's over 2, then that's your indication you're using the half angle. Alright, now we do have free choice because it's tangent, and I told y'all already in advance that I choose the one right here because I like on the bottom there to just be the one thing, and there's also no giant square root. So I'm going to copy right here. The formula is 1 minus cosine. Now, look at how the formula works. You see this? That says cosine x. What was up here? X over 2. So what is my x? 45. So don't come right here and put 45 over 2, because that's, remember, the idea is that the half angle identity is letting you take something that was over 2 and put it into just calibrated reference angles. So you got 30, 45, or 60, or 90, or 180, or 270. All right, so this is cosine 45 over sine 45. You should gather where we're going with this. We need to know cosine 45 and sine 45. Where do I get that? Unit circle. You got your unit circle right in front of you. Find 45 degrees. Cosine is the x-coordinate. I wrote this like that. Sine is the y-coordinate. Okay. Take this since I'm in that one. All right. This is the answer, but you got to clean it up. You can't leave it like that. Now, on the test, if you get this far, you'll get partial credit. But you've got to use your basic rules of like combining fractions and then keep, change, flip. So this kind of goes back to that really ugly tangent problem from 7-1. Remember me saying tangent's the worst here because it involves all these fractions and you got to keep, change, flip it. That's what's involved here. So we've got 1 minus this fraction. We need that to be one fraction on the top. I love having a 1 because I just change the 1 to whatever the denominator is of the fraction I'm combining it with. 1 in terms of 2 is just 2 over 2, right? You go with me? Just 2 divided by 2 is 1. So I'm going to rewrite, and I'm running out of room. I'm going to come up here, right here. So I'm going to write 2 over 2 minus root 2 over 2 over root 2 over 2. So all I've done here is change the 1 to that. Okay? Now, in that top, I can write that as just one fraction. And read it carefully. So we've got, across the top, we've got 2 minus root 2, and it can be written over 2. So 2 minus root 2, and it can be written over 2. Now, I've got my really big fraction bar. Draw it really big so you don't forget where you are in your fraction. And then I've got this thing on the bottom. And then enter, keep, change, flip. And things are going to cancel nicely. Okay, so keep it, change it, and flip it. So what cancels? That 2 and that 2 cancel. Right there, we changed colors. That one and that one. Now this is as bad as it gets. I told you, let's dive right into one of the challenging ones, so then the next ones are not as bad. Alright, so once again I wrote that. Here we go. So going across the top, I've got 2 minus root 2 all over root 2. I think my math lab might let you stop there. I'm going off of the way where they let you stop with 7-1 with that one tangent problem. So if my math lab will let you stop there, then by all means stop here. If it says, although your answer is correct, you need to rationalize the denominator, then let's go ahead and show you what that would look like. It's not bad, it's just, hey, the bottom is root 2. This is exactly why I picked that one. Right? I picked that one so that the bottom is one thing. So the bottom is root 2, so I need to multiply by root 2 over root 2. You do have to be careful because on top, you have 2 terms up there. So when you multiply that root 2, take it to both of them. Okay? So rationalized, it would look like this. 2 root 2 minus, what's root 2 times root 2? Root 4, which is 2. Thank you. And then on bottom, once again, root 2 times root 2, which is root 4, which comes back to 2. Now, that is also the correct answer. However, yeah, there's a common factor of 2 in every single term that can divide away. No, I do not mean this one. This one right here is protected. Don't you dare cancel that one. I'm talking about this one, and this one. So if this goes into here, that'd be a 1, and then that would be a 1. So root 2 minus 1 is technically the final rationalized, cleaned up answer. And then now if we go to our calculator and type, what's the square root of 2 minus 1? Bam. Same decimal that we started with. Now, let's refresh, or recap on this, okay? Because I know tangent, I said we're diving into the hardest one first, so that everything from here is easier. I say that loosely. So we set it up. We said we got to find pi over 8. Because the directions said then check your answer, then I went ahead and typed it in to kind of get an idea of what my decimal should be. I took pi over 8 in radians and I converted it to degrees and kept it as a fraction, which is what nicely set me up to know what x is. X is 45. I plugged it in the formula. Then I went to my unit circle and found those values. I feel like everything from here to like here is probably fine. I probably started losing people when we got here. And that is just cleaning up, fractions being added or subtracted, and then cleaning up, keep, change, flip, and then rationalizing. So please don't, you're in a college level class for a reason. You're capable of this. Don't let me lose you on this part, because this is stuff that you've been doing for years. It's just, you're just fatigued, you know? You already went through this mess, and it's just like, good Lord, can I not just be done? And no, you can't, because it's college. Let's practice 2 more. They're not as intense. All right. Look at the first one, E3. It says tan of theta is negative 3 over 4. Then it says theta's in between 270 and 360. Then it says find sine of the half angle. Okay, so this is saying I'm in what quadrant? Quadrant 4. Now, here's where you gotta be careful. my single angle is in quadrant 4. I'm going to draw my picture based on that, right? My half angle, my answer, when I get down to here, my half angle should have a sign that reflects taking the single from quadrant 4 and cutting it in half, right? Go with me? So keep in the back of your mind, watch your signs. If you do all of this work right and your sign is the only problem, you're going to get only 1 point deducted from the question itself. You'll get 1 point deducted for having the wrong sign. Okay? I don't believe in saying the whole thing's wrong just because your sign's wrong. Technically, the whole thing is wrong. But you have all of the meat of it. You just forgot to remember what quadrant you're in. All right. Let's sketch the picture. We're in quadrant 4. Quadrant 4, draw from coming out of the origin, collapse it to the x-axis, put your theta there. They're giving you a true function to start with, which means they're giving you 2 signs. This should seem familiar. They gave me tangent. Tangent is y over x. So the y-coordinate's 3, the x-coordinate's 4. Which one should be negative? 3. And do I really need the Pythagorean theorem here? Nope. It's a 3, 4, 5. Let me show you something. Be careful with 3, 4, 5 triangle. Always make sure that the 5 is on the hypotenuse. If you had a triangle, let's say it was like that, I don't know. Don't shove a 4 in there just because you see 3 and 5. Always make sure that it would be on the hypotenuse, okay? Alright, so we've got our triangle labeled. Now we're ready to go to our formula. This is a lot like the double angle concept. You know, they gave us a true function to start with. What quadrant? You draw the picture, you label, you find the third side. You've got the formula. Go to your formula sheet. We are doing sine of a half angle. There's only one formula. We're going to write plus or minus here so that we don't forget to pay attention to our sign. We'll determine it at the end. Or you could do it here if you wanted to, but I just like to say at the end, all right, what's my sign? What's it need to be? All right, the formula is 1 minus cosine theta over 2, right? So now we're going to plug in cosine theta from our picture. So bring this down. 1 minus, what's cosine from our picture? Adjacent over hypotenuse, or x over r, what would that be? 4 over 5 over 2. Now, here's why this problem is not as labor intensive as the last problem. The last problem was tangent. Tangent usually involves radicals, right? Square roots. Cosine and sine usually don't. The picture that we had didn't have a square root here. In the last one, we had a square root. You don't have to go through that whole mess of cleaning this up by hand. You can type just the radicand part in the calculator and say mathfrak, and it'll come out as a nice number because there's no radicals in that mess. So I'm going to go to my calculator. Don't enter the radical because then you're going to get a decimal. Don't enter the radical. I'm going to type exactly what I see under the radical, which is 1 minus 4/5. I'm using the shortcut from typing a fraction here so that I don't have as many keys to press. Over 2. 1 over 10. There you go. So this mess right here is actually just that mess, right? Now you need to determine your sign, and you need to rationalize. That right here, isn't that the same thing as this? Yes? Same thing, right? When you have the square root of a giant fraction, you can separate it as just square root of the top over square root of the bottom. Why would I want to do that? Well, because what's the square root of 1? 1. And then the bottom is square root 10, which means now I know what I need to rationalize by. What are you going to use to multiply by? Square root 10 over square root 10. And I wrote too big, so hold on. Actually, let me just do that. Alright, so that right there is just 1 over square root 10. I'm going to rationalize with square root 10 over square root 10. And we end up with that, right? Now don't cancel those 10s out. One's in a radical, one's not. Can't cancel those. Now you need to ask yourself, what's the sign? Okay? Well, if we were in quadrant 4 with this single angle, and we've cut the angle in half, then we've most likely landed in quadrant 2. What is sine in quadrant 2? Positive. So that's the answer. Okay? So you might want to take some notes on how we got there. You can put a plus sign in there if you want. But anyways, let's make it up. Change colors. If theta is in Q4, then theta over 2 is in Q2. And then we said sine is positive in quadrant 2. All right, do you want to do this practice example? Do you feel like you need another one? Possibly. All right, so set it up. Look at what quadrant you're in based on the theta. Draw the picture, find the missing side, pull a formula for tan of the half angle. What quadrant are we in? We're in quadrant 2, right? This means between 90 and 180. So if we're starting in quadrant 2, we're cutting it in half, where do you think we're landing? Because remember, it's a half angle. So if we're in quadrant 2, so the most you could be is up to 180, right? So if you cut that in half, you would land at 90, which means we're in quadrant 1. Y'all with me? So think about it. If you're between 90 and 180, they're telling you, hey, you're between 90 and 180, and you cut those in half, then that would mean we're between like 45 and 90. Technically, think about it. 90 and 180, just divide those numbers by 2. So we're landing in quadrant 1. So you can make note to yourself, like an arrow, to say, okay, so theta over 2 is in Q1, which is going to let you know all the signs are positive. All right. Alright, so, but we draw our picture though based on theta. We draw it based on what they give me, because they're giving me the single angle, not the half angle. Alright, so quadrant 2, come out, collapse. They gave me sine, that's y over r. Thank goodness 5 is on the hypotenuse, so x is -4, right? Because you are over in quadrant 2. Alright, y'all know me with the tan. I'm just gonna, for the video, I understand you're gonna pack up. I'm gonna finish it for the video. I got 1 minus cosine over sine. That's the one I use. So the beautiful thing is here, there's no square root symbol, which means there's no rationalizing, which means once you plug in your fractions, you can go to your calculator and type the whole thing in and get the final answer. You're done. Nothing to do here. So I've got 1 minus the -4/5 over 3/5, and I would type that in. Math bracket, no need, it's a 30, right? Oh, so this just all went, let me make it up, this all went in the calculator, and we got 30. Tomorrow, I will start class with 7-2 homework problems. It is not due tomorrow. You're welcome. Oh, perfect. That doesn't mean don't work on it. Right. No.